Hey guys, Mr. Milton here. Today we're going to look at rate of change. And then in this video, you should be able to find the rate of change between two data points, and you should be able to put your answer in the context of the problem. Okay. The rate of change allows you to see the relationship between two quantities that are changing. In a line, the rate of change is constant. Okay, and when you say the rate of change is the change of the y over the change of the x. Okay. So you can think of that way. You might even say rise over run. You might see it written as delta y over delta x if you're looking at like old school math things. Okay, so this problem says find the rate of change from a graph. We can find the rate of change from a graph here. These next two examples. Okay, so as we look at this, then we're noticing that what we said is the rate of change should be constant. So as we look, I can identify 1, 2, 3 points here. Maybe I should have used blue so we can see them a little easier. Okay, 3 points where I can clearly identify them. Now there's points all the way along the line, but I'm choosing these 3 points that I can easily see what they are. Okay, and so from 1 to 2, from point 1 to point 2, how much is being changed? So as we look, this whole thing is worth 1, so I'm going to say that, or $1, so I'm going to say each of these lines is 50 cents. So how much does the line change from point 1 to point 2? Well, it changes 50 cents for 0.5. How much does x change? Well, it goes from 0 to 2. Okay, so it changes 2. What is the rate of change? Well, as we look at it, we could say 0.5 over 2, which I don't love because like 0.5 over 2, what does that mean? Okay, but what does this mean? It means that it costs 50 cents per 2 ounces of oregano. Okay, from 2 to 3, how does it change? Well, we go from 50 cents to $1. Changes 50 cents. It goes from 2 to 4. So how much does x change? Still 2. 50 cents per $2. How does it compare to the rate of change from point 1 to point 2? It's the same. Okay, and this is just showing us that that rate of change is going to be constant. Okay, as we look at this, I might look at this better and say, well, it costs $1 per 4 ounces. I like that better than 50 cents per 2, but you'll notice that it's the same. Okay, and our next problem, look at rate of change in a graph. Here we have a tank of gas. The y is measuring the fuel in the tank. The x is measuring the miles traveled. So again, it doesn't matter which points we choose, but we will want to choose things that we can clearly identify. So I see this is 15 gallons in the tank, 0 miles driven. You can see that easily. And then here, I have 5 gallons in the tank, 150 miles driven. Okay, so we're at 150 and 5, and we're at 0, 15. Okay, so how much does the y change from these 2 points? Well, it goes from 15 to 5. So the difference here, how much does it change? Negative 10. Okay, notice that we included the negative because it's going down. How much does the x change? Well, it goes from 0 to 150. So it goes up 150. So what is the rate of change? Negative 10 over 150, or better to say negative 1 over 15. So in this situation, what does it mean? Well, let's look at what our labels are. Negative 1 gallons, lose, so you lose 1 gallon of gas per, and what's our x? 15 miles traveled. Or we can just say 15 miles in the car. So basically, your truck is getting or car is getting 15 miles per gallon. Okay, we can also find rate of change from a table. Okay, we want to see, is there a consistent rate of change or a constant rate of change? This is how we can see this. It's not going to be whether the numbers are the same, because as we look at this, 2 goes from here to 2, goes from here 3, goes from here 1. The number of tickets that are sold changes, 2, 3, 1. The cost is changing as well, 30, 45, 15. Okay, and so if we just were looking at like how the number of tickets changes, it wouldn't be the same. Or if we were just looking at the cost, it wouldn't be the same. But if we're looking at this situation like a real world situation, we're talking about the number of tickets and how much it costs, we'd expect if we're going to the same show or play or event, we'd expect the tickets to be the same. Like if I could buy 7 or 5 or 10, we'd expect that price to be pretty consistent. Okay, so remember that our rate of change is the change of y over the change of x. Okay, this is x, this is y. Okay, and so as we look at this, we don't want to look at just this column or this column. We want to say, how does the change in y compare to the change in x? Our y's changed 30, our x was 2. That simplifies to give us 15. Over here, our y change was 45, our x change was 3. 45 divided by 3 gives us 15. Here, our y change was 15, our x change was 1. 15 over 1, 15. What do we notice about all these fractions? They all simplify to 15, or 15 over 1. Is their rate of change constant? Yes. What is the rate of change? 15 over 1. Well, what does that mean in this case? Okay, so now we're looking at our labels and making sure that we're assigning those correctly. It means it costs $15 per ticket. I'll just say one ticket because that's what it is here. Okay, each ticket costs $15. That's what our rate of change means. So we look here. 5, 3, 4. Notice that all these different. 20, 10, 50. Okay, so again, our y over our x, 20 over 5, simplifies to 4. 10 over 3, ooh, that's like 3 1/3. 50 over 4, what is that? 25 over 2, yeah. So 4 over 1, 10 over 3, I can just leave it as that. Fractions might be a little bit easier here. That's simplified to 10 over 3. That simplifies 25 over 2. Simplified, is there a constant rate of change? No, not a constant rate of change. Okay. Okay. And so as we look at this, when there's not a constant rate of change, we can't say that there's a rate of change here. Okay. And so what does it mean in this problem? Well, it means that while we're running, our speed isn't constant. Okay, in this situation. And that kind of makes sense as you think about running. Like, for the first 5 seconds, you might have been really fast, and then for the next 3 seconds, you kind of slowed down, and for the next 4 seconds, you were still slower because you started getting tired, maybe. Okay, but it means that the speed wasn't constant in this situation. Okay, so it doesn't always have to be constant, and we noticed that by comparing how our y was changing compared to our x each time. Okay. We can also find a rate of change from 2 points. Okay, and really we were already doing that in the table, but here we're going to be given 2 points a little bit differently. Okay, so it says the baby giraffe was 70 inches tall at birth and 103 inches tall after 3 years. What are the 2 points of data we can get from this? Okay, so as we look at this, we're like, okay, wait a second. They didn't give us 2 points. They just gave us a sentence. So as we look at this, we might say, hey, they didn't give us 2 points, they just gave us a sentence. And so what we're going to do in the sentence is say, what information did they give us? Well, they gave us years, or age, however you want to say that, and they gave us height. In years, it's going to be our independent because we can't control that. Okay, when the giraffe was 0 years old, it was 70 inches tall. When the giraffe was 3 years old, it was 103 inches tall. Okay, so only 1 or 2 points of data, not really asking if it's consistent or not. We can say, how much does this change? This one up plus 33. How much does this change? This one up 3. Okay, and so what is our rate of change? 33 over 3, or 11 over 1. Okay, and so as we look at this, we're like, okay, well, what does this mean? Well, it means that this giraffe grew 11 inches per 1 year, or just per year. Okay, and so what we did was took this information, put it in a table, and was able to find the same things whether we were given a graph or a table. Okay, and since we kind of converted it to a table, works out. All right, so another one. We have days, eggs. It says after 3 days, the farmer had collected 38 total eggs. After 7 days, he had collected 194 eggs. So 3 days, 38. 7 days, 194. So kind of put that here. What are our 2 data points there? 3 and 38, 7 and 194. What is the rate of change then? Well, how much does this change? That's 156. And that's 4. And so we could say 156 over 4, but we should try to see if we can simplify that any. And that does simplify. That gives us 39 over 1. That's what it says. So what does it mean in this problem? It says, on average, you got 39 eggs per day. Yeah. All right, so that's how it works out. Okay, so that's rate of change, making sure that we can do that from a graph, from a table, and from 2 points. Okay, see ya.